Okay, good morning, please. And, I hope you had a good weekend, and I hope you're keeping safe and up and alive. And, here we are again today on another lecture. I hope you also okay. So please, each time we have a lecture, it's important, that you get involved and get participatory, and would have time later on to look at it. That means you would have wasted your time following the lecture now. And don't be among those people who think, okay, I'll get the video later on and look at it. No, there is always a kind of, okay, it would also be the same thinking like, oh, the president is giving a speech, no, they will replay later on. The flavor of it would have been last, okay? So please, it's a matter of discipline too, and it also teaches you to be upbeat and to keep pace with what is happening, okay? Yeah. And then even as we keep on moving, I got up this morning contemplating, what if the schools were closed or are to be closed indefinitely, and there will be no online classes and we don't have the facilities to go online and teach? And probably maybe we have no emails. What would you do? Okay, what will you do? What will be your living? Okay, it's very important and very vital. Okay, so you don't mortgage your life thinking life will only resume when school resume. Life wouldn't only resume at that time. So you need to be active and alive. Okay, you need to be active and alive. Okay, don't peg your life to just school. Okay, be active and alive and be upbeat. Okay. And so it's one of the things we live in a time and a dispensation that we interact with as many people as we can. And there's one key ingredient that helps us go through life easily, and that ingredient is what we call fervor. Okay, fervor. It's a flavor. It's an influence on a person that causes that person to be accepted, causes things to happen for that person at ease. Okay. Now we've always heard that favor is more celebrated than labor. Okay, because if it's labor, there are people who labor a lot but they get nothing. But favor just gives you many things. Okay, so favor is important. One of the gateways to favor is honor, and I just wanted to talk in a few minutes about honor. Honor is a gateway to favor. When you honor people, you honor your siblings, you honor your parents, you honor your neighbors, you honor people. It's a gateway to favor. Okay. And what is honor? Honor is you recognize, you acknowledge, you celebrate, and you reward the uniqueness of another person. Okay. You recognize, you acknowledge, you celebrate, and you reward. Okay, so you need to have that ability to discern uniqueness in another person. Okay, you left secondary school, and then how do you discern your classmates, your siblings, your parents, and your guardians, wherever you are, the ability to recognize, to acknowledge, to celebrate, and even reward uniqueness is honor. Okay, and honor is a seed. Okay, honor is a seed. When you honor people, you sow a seed of being honored. So learn to discern honor. We close doors by dishonor. Learn to discern honor. Learn to honor one another. Honor your siblings. Honor your words, your network friends. Honor your parents. Of course, we've always been taught in primary school that is the first commandment that has a promise. Honor. You see, you don't know how much you will lose by dishonor. And honor is your heart. First of all, it's not just by vocalization, it's your disposition. It has a body language, it has a flavor, it has a communication. how you honor people. Okay, please learn to honor. Learn to honor people at home. It's a seed. It's a seed. It's a seed. It's an investment. Learn to honor your lecturers. Learn to honor your parents. Learn to honor your leaders. It's quite important. You can afford to be the same. Okay, you can't afford to be the same. I've seen, and this is reflected in your respect or disrespect or arrogance. Okay, or arrogance. You can't afford to be like other people who, because of who they are, what they have, where they come from, what they do, or what they put on, they are arrogant, they're disrespectful. A medical worker with difference. Okay, please, you can't afford to be like any other person. Let honor be part and parcel of your daily living. Okay, make it culture yourself, because the honoring of somebody sometimes touches on our pride. Okay, and you have to learn, educate yourself. I have to keep on honor in my words, in my thoughts. Right? And it's not what you tell your parents, it's your disposition in your heart, what you think towards them first. That shows a sign of honor. And the same thing you do with your siblings. You don't just honor your seniors, you also honor your sons of what? A way of your GTs. Okay? Life is sometimes in circles. Okay. So you learn to cultivate that. Please, I think uh, I've made exactly more than a year here, and one of the things I've observed is that not many, you don't have to be disrespectful. You don't, whatever you think you are, or whoever you think you are before, wherever you are, probably maybe you left a secondary school where they were celebrating you as a king or the queen, or in your family, you are the king or the queen. But when you come to school, know that you have met other queens and other kings. Okay, so you gather, many kings have gathered. So learn to interact with people with a courtesy of respect. They say nobody knows tomorrow, but no, tomorrow is a bright one, but it could be brighter for others than for you. Okay, so learn to relate with people with a sense of decorum. Okay, with a sense of honor. Honor your classmates. Huh? You may think you have all you need, you have now. Tomorrow can never be guaranteed. I think, and the person you're smashing now, tomorrow may be a boss, and for an attitude you portrayed, or getting it somehow will deal back with you. Life is a seed. Whatever action you do, whatever thing you say is a seed. You are planting a seed. So don't be surprised what you harvest in the future. What you're harvesting now is a seed you planted 2 years ago, 5 years ago, 10 years ago. So if you're not comfortable with the seeds you're harvesting now, start sowing different seeds. And even if you are comfortable with the ones you're harvesting now, you can harvest better ones. So try to sow good seeds in actions, in words, in thoughts. Learn to honor. Learn to honor people. Learn to respect people, learn to accredit people, learn to recognize difference, learn to recognize influence. Right? Irrespective of what you may say, a security man at the presidency is much more valuable than the king in his village. Why? The positioning. So please learn to do that. Life is full of things we need to learn. So today we would commence with erythrocytes. Last week we talked about plasma fluid and we talked about plasma proteins, okay? And we're able to discuss so many of the plasma proteins, and then we mentioned their clinical significances, their physiological functions. And today, so we want to look at erythrocytes. It's going to be an interesting discussion. And then, so please, when you want to ask your question, ensure you portray the courtesy of communication. Please can you kindly repeat that question? And then somebody, and if as somebody asks a question and you can also answer as a student within the chat line. Of course, you've been doing that before, and that's wonderful. Okay, so far so good. It's been great, and you are welcome to today's class, and we hope to be on time. So we're talking about erythrocyte. We started by introducing the concept of blood, and we said blood has a corpuscular component and a fluidic component, okay? And the corpuscular component is what we call the cellular component. And then we mentioned 3 types of cells. We mentioned the red blood cells, which are also called erythrocytes, and we mentioned the white blood cells, which are called leukocytes, and we mentioned the platelets, which are also called white cells. Okay. And we mentioned that the average red blood cell count is about 5 million. We'll look at it in details today. But then let's first of all look at the structure of the red blood cell. Okay. we say a mature red blood cell is enucleated. It lacks a nucleus. Okay, it's biconcave in shape with a diameter of about 7.5 micrometer and a thickness of about 2.5 micrometer at the periphery and 1 micrometer, 1.2 micrometer at the center. Okay, so we talked about what the shape of the red blood cell is what is a biconcave disc. Okay, can we still remember convex and concave? Okay, so it's a what? It's a biconcave. It's a biconcave disc. Okay, on both sides. So it has a diameter of what 7 to 8 micrometer. Of course, an average of 7.5 micrometer. A thickness of about 2.5 micrometer at the periphery, and around 1 to 1 micrometer in the center. Okay, we could the red blood cell. Okay, so the first thing which we establish is that what the importance of this biconcave shape of the red blood cell. What is the importance of this biconcave shape of the red blood cell? The first one is that what it enhances diffusion of the respiratory gases into and out of the cell. Okay, it enhances what? It enhances diffusion. It enhances diffusion of the respiratory gases into and out of what? Of the cell. What are the respiratory gases? Oxygen and what? And carbon dioxide. Oxygen and carbon dioxide. So the oxygen gets in, the oxygen gets in and also gets out, the carbon dioxide gets in and gets out. Okay? So the biconcave disc enhances what? Diffusion of respiratory gases into and outside what? Of the cell. How? Since this biconcave disc, it has what? It has a large surface area because the biconcave disc, it makes the red cell flat, almost flattened, and increases what? The surface area of diffusion of gases. Secondly, it because of what? The diffusion distance is also reduced, okay, especially at the center. Okay, so see it has what it has both a greater surface area and a shorter distance at the center of the cell. Okay, flexibility permits the red cells to permeate, okay, to bend easily and squeeze through narrow capillaries. Okay, so it helps, it permits the red cell to be flexible, to insinuate itself, to move, to squeeze itself through narrow capillaries. So what are the two things we've seen that are important in the biconcave nature or biconcave shape of the red cell? Okay, permits for diffusion of gases into and outside, and what the issue of what? Flexibility, and permits the red cells to permeate themselves narrowly through tight capillaries. Okay. Then another when the red cells swell after combining with what? With oxygen. Okay. So it keeps the tension on the membrane minimal when the red cells have what? Picked up carbon dioxide. Because when they pick up carbon dioxide with that large molecular size, the cells at least swell, and so the shape of the red cell helps to maintain that tension to minimal levels. Okay, so we've seen three important consequences of the biconcave shape of the red cells. Okay, then another cells are what are enucleated. That means they lack the nucleus. Of what importance is the absence of a nucleus in mature red cells? Okay, of what importance? So it is important that without a nucleus, there is enough space for hemoglobin in the red cell. Okay, there is space enough for hemoglobin what? In the red cell. In the red cell. Okay, so that is important. And then we also say mature red blood cells lack mitochondria. Okay, lacks what? They lack mitochondria. Now, what is the importance of mitochondria? Mitochondria are cellular organelles, which, as we mentioned earlier on, that are the energy factories of the cell, And so their role is what? To synthesize energy. Okay, their role is to generate energy in the form of ATP. And how do they generate energy? They generate energy by using oxygen to oxidize oxidative molecules in the cell. Okay, they use oxygen to generate energy. So imagine that if the red cell had mitochondria, what happens? Instead of the red cell carrying the oxygen, the mitochondria of the red cell will use the oxygen. Okay, so for that to be affected, the red cell should be devoid of what? Of mitochondria. Okay, so that is important. But then, how then does it survive? One, okay, about 1,000 to one, and so the average lifespan of the red cell is about what? 120 days. 100 to 120 days. That's about 4 months, right? Okay, and then we'll see. Why we said the average red cell count is 5 million. It's 5 million. But then it's about averagely 5.4 million in males, 4.8 million in females, and about 6 to 8 million in what? In newborn. Okay, about 6 to 8 million in newborn. Okay, so we would look at now the physiological variations of red blood cell, but then at this point we'll just concentrate on polycythemia. We'll look at anemia detailedly almost towards the end of the subject matter. Okay, so look at polycythemia. Okay, what is polycythemia? Or polycythemia or erythrosis or erythria. Polycythemia in itself is more or less is pathological, and the second way is what? It's a physiological polycythemia. Okay, so primary polycythemia or polycythemia is a disease condition in which there is excessive production of red blood cells due to an unknown cause. Okay, it's a disease condition in which what? There is excessive production of red blood cells due to an unknown cause. So just imagine, what did we say was the average red cell count? We say was about 5 million. Okay, if we have a pathological condition, if we have a situation in which the red cell count is increased uncontrollably, what happens? Let's look at the consequences. First, this would increase what? The hematocrit. Okay, can we still remember the hematocrit? The percentage of blood that is made of what? Of red cells. Okay, it would increase the hematocrit. Secondly, it would increase the blood volume. Okay, because we have many red blood cells, right? We said the blood is made of what? Cells and fluid. And the blood volume is what? The volume of the cells and the volume of the fluid. Okay, so if the volume of the cells increases, the volume of the blood invariably increases. So what is the third thing that could happen? We have an increase in what? Viscosity. The blood becomes thick. Yeah, the fluidity, the rate of movement, okay, the fluidity of the blood, the consistency of blood becomes what? Reduced. Okay, so the blood becomes thicker. Okay, so an increase in blood volume. So what happens when there is an increase in blood volume? Okay, when there is an increase in blood volume, we have an increase in venous return. Okay, when we have an increase in blood volume, the venous return increases. What is the venous return? The venous return is the amount of blood returning to the heart. Okay, is the volume of blood returning to the heart. True, of course, and blood returns to the heart through what? The veins. So call it what? The venous return. So because there's an increase in blood volume following an increase in the red cell count, there is what? There is increased venous return. But now we have also mentioned that what? The viscosity of blood reduces. That means what? The flow of blood, the rate of flow of blood reduces. So this would override. This will override what? It will override the increase in venous return. So in another sense, the increase in venous return increases what? The cardiac output, while the decrease, the increase in blood viscosity would decrease what? The cardiac output. So the cardiac output is almost maintained. But there's another aspect that brings that is as a consequence of the increase in viscosity. Because when there's an increase in viscosity, it increases the peripheral resistance. Okay, so it increases what? The peripheral resistance. Okay, it increases the peripheral resistance, and this tends to what? To elevate the arterial blood pressure. Okay, it tends to elevate what? The arterial blood pressure. Okay, what? Because the blood and the periphery becomes what? Thick. It resists flow, and this sets up what? A pressure. Okay, it sets up a pressure. Now, another thing that is a consequence of this increase in blood viscosity is the what? The rate of flow reduces. The rate at which blood flows reduces. So there's some level of stagnation. Okay, there's some what? There's some level of stagnation. And what is the primary function of the red blood cell? Is to what? To transport oxygen into the tissues. So when the rate of flow of blood to the tissues drops, what happens? The rate at which oxygen is delivered to the tissues also drops. So what is a decrease in the oxygen levels at the tissue? Hypoxia of blood to the tissues. The rate at which oxygen is delivered to the tissue reduces. So we have a decreased oxygen level at the tissues. So we have hypoxia. Okay, so if what kind of hypoxia? We call it what? Stagnant hypoxia. Why? Due to the blood stagnation. Okay, due to what? Blood stagnation. So we have a decrease in the levels of oxygen at the tissues. Okay, due to what? Blood stagnation. So we call this hypoxia what? Stagnant hypoxia. Okay, stagnant hypoxia. So you see how we've been able to relate the increase in erythrocyte count to different parameters, to hematocrit, to blood volume, to blood viscosity, to blood pressure, to cardiac output, and to what? To hypoxia. Okay, so we did some about what? Primary polycythemia. So let's look at secondary polycythemia, which is what? Physiological polycythemia. Secondary polycythemia, or what? Physiological polycythemia. So what is this? It occurs whenever the body suffers from oxygen lack or suffers oxygen lack. Okay. What is oxygen lack? Hypoxia or hypoxemia if it's in the blood. So but then when there's oxygen deprivation at the level of tissues, there's hypoxia. What happens? Hypoxia is the main stimulant for production of red blood cells. So when there is hypoxia, it stimulates the production of red blood cells, and we'll discuss that in details when we come to erythropoiesis. Okay, when we come to erythropoiesis. So when we talk of secondary polycythemia, talking about physiological polycythemia. So what type of hypoxia did I mention? It's stagnant hypoxia. In Nonge, yes, in Nonge Katundu, it's stagnant hypoxia. You're correct, that's what I did mention. So will you kindly comment on how the red blood cell activities are controlled since the increase is absent, or which organ is responsible in the case of red blood cell? Kabinga, could you rephrase your question properly? Okay. Could you rephrase the question and be clear with what you want to understand? So how the red blood cell activities are controlled. Oh, that's beautiful. How are they controlled? Number one, it also tells us that's one of the things they have a restricted lifespan, and how are they controlled? We would come to that when we come to red cell metabolism. Okay, that's a beautiful question. And which is responsible in the case of red blood cell? I didn't understand that last part, but then I think we will look at that when we come to red cell metabolism. Okay. So we are talking about secondary polycythemia. Okay, of course, when the body suffers oxygen lack, and this oxygen lack or this oxygen deprivation stimulates what? Stimulates erythropoiesis. Okay, and how do most of the times this condition occurs when individuals go at high altitude, because for every 100-meter rise, the partial pressure decreases by 1 atmosphere. Okay, for every 100-meter rise, the partial pressure decreases by one atmosphere. So if you keep rising as the partial pressure decreases by 1 atmosphere, the partial pressure of oxygen is decreasing. Oxygen available for usage decreases. Okay, and I'm sure we will look at that or you may consider that in respiration. That's the next topic, hopefully after that. Okay. So we could also have newborns, okay, could also suffer in intrauterine life. That means during pregnancy, the developing embryo or the fetus um, experiences some level of oxygen deprivation because the fetal blood has to get oxygen from the mother across the placenta. The lungs of the fetus are non-functional, and so there are mechanisms by which the fetus mops up this oxygen. First of all is by producing several red blood cells, okay, about 6 to 8 million. And secondly, by also having a hemoglobin that has a higher affinity for oxygen than maternal hemoglobin, okay? So that is why you would have the red blood cell count in utero and immediately after birth for about up to 3 months in the fetus and one in newborn. Okay, this hemolysis of the red cells also avails the products of metabolism, which include amino acids, iron. So the iron that is gotten up from this breakdown of excess red blood cells is stored and can be used and is used by the infant for other metabolic processes, especially in formation of more red blood cells. So within this period, the infant may not require iron supplementation, but afterwards, maybe from 6 months to 9 months, there's need for exogenous iron supplementation. Otherwise, the infant could suffer iron deficiency anemia. Okay, the infant could suffer iron deficiency anemia. Okay. So that is important. So now we look at the red cell structure. We've mentioned that it is biconcave, right? So and we look at the membrane. So the membrane of a red cell is like a typical membrane, which is a lipid bilayer. It's a lipid bilayer with integral and peripheral proteins. Okay, can we say remember integral and peripheral proteins? Yes, you can think about this. So the integral proteins, they span all through, while the peripheral proteins at the periphery on one side of the membrane, either inside or outside, either intracellular or what, or extracellular. Okay, and so the carbohydrates on the surface are mostly glycoproteins and glycolipids. Okay, they are mostly glycoproteins and what, glycolipids, which have blood antigen properties. Okay, blood grouping properties. Okay, they have what? They have blood group specificity. Okay. Then inside the cell membrane, the peripheral proteins form an extensive filamentous network called the red cell membrane skeleton, called the cytoskeleton. Okay, so we have the peripheral proteins on the inside of the red cell membrane form an extensive filamentous network called the red cell membrane skeleton, or called the cytoskeleton. So remember, we're talking about the membrane, which is a lipid bilayer having integral and peripheral proteins, and then the carbohydrates are mostly what, glycolipids and glycoproteins, and they have blood grouping specificity. Okay, we'll look at that detailedly. Okay, and then I said the peripheral proteins on the inside of the red cell have an extensive filamentous network, what we call the red cell membrane skeleton or cytoskeleton. Okay. Okay, what is the name of the filamentous network? We call it a red cell membrane cytoskeleton, red cell membrane skeleton or cytoskeleton. Then kindly repeat on erythropoiesis. We'll come to erythropoiesis, Victor. We'll come to erythropoiesis. I just highlighted is the production of red cells. So we'll come to it in details. Okay. So So this, what is the importance of this cytoskeleton? It is essential for the maintenance of the shape and deformability of the red cell. So this cytoskeleton, which is just beneath inside, is it forms a cytoskeleton, and it's important for what? Maintaining the shape and deformability of the red cell. Somebody's asking which ones have antigens, glycoproteins or glycolipids. All of them. We'll come to look at them when we come to that. Okay. Okay. So we're looking at the red cell membrane. That's why sometimes questions come in and obstruct my flow. So we've looked at the cytoskeleton. We've looked at now the importance of the cytoskeleton is maintaining the shape and the deformability. Then there are some integral proteins that now are affixed to what? They are affixed to the cytoskeleton. So we have integral proteins. Example of these integral proteins are protein band 3 or protein 3 or band 3 and glycophorin A. Okay, so this glycophorin A and protein or band 3 are tightly bound to the membrane and act as anchors for the underlying membrane skeleton. So we have the cytoskeleton intracellularly, and then you have these integral proteins, banturin, green, okay, we have spectrin, we have ankyrin on the red cell on the cytoskeleton, and we mentioned what? We mentioned banturin and what? Glycophorin A. So that if you have defects in the proteins of the cytoskeleton, you could have a deformability, you could have the shape of the red cell will be altered. So some of them could be like it could be spherical, some could be what? Elliptical. So that's why we have conditions like hereditary spherocytosis, hereditary elliptocytosis. The shapes of the cells are what? Altered. Okay, some of them are spherical, they are what? Elliptical, due to what? Defects in the proteins of the cytoskeleton. Okay, what are the proteins in the cytoskeleton again? Okay, so Lindiwe, that means you didn't read your PowerPoint before today's lecture, right? So those are, so you have glycophorin A and protein band 3. Those are integral proteins that anchor on the what? On the cytoskeleton. Okay. Then ankyrin and spectrin are proteins in the cytoskeleton. Okay. So having looked at that, the integral membrane protein also serves other functions. Okay. One of them is that it has binding sites for several glycolytic enzymes. Okay. Now, and the others serve as transport for bicarbonate and chloride entering or leaving the cell. Now let's come back again. Let's take it keenly. Remember, can you remember when we were talking about chloride shift? And we mentioned about how chloride enters and bicarbonate goes out. Of course, that means and they go out through what? Through channels. And these what are channels? What are the functions of membrane proteins? We mentioned earlier that in one of our earlier lectures that what protein channels serve as what? As proteins, membrane proteins serve as what? Channels. So they could have they function as channels for the exchange or for the movement of what? Chloride and bicarbonate. They also serve as, we also said what? They also serve as what? Membrane proteins could also serve as enzymes or what? Binding sites. Okay. So here they serve as binding sites for several glycolytic enzymes. Okay. And if you remember, I mentioned to you that the red cell membrane does not have what? Does not have mitochondria. And so it doesn't produce, so we don't have the mitochondria to produce energy. Then how then does it derive its own energy? Okay, one of the processes of energy production in the cell is glycolysis. Glycolysis is it's a highly conserved metabolic pathway that occurs in almost all cells, um, and in almost every organism, where uh, monosaccharides are broken down to release what? Energy. Okay, so the red blood cell uses two major pathways to generate energy. Okay, one is glycolysis, and the other one is what? Pentose phosphate pathway. Pentose phosphate pathway, or the hexose monophosphate shunt. Okay, so the integral proteins serve as binding sites for these enzymes. Okay, on the membrane proteins again, what do we have? We have sodium potassium ATPs. Okay, the sodium potassium ATPs is a pump. We remember we talked about sodium potassium ATPs. Of what importance is this? If it doesn't pump the sodium out, what happens? The sodium will stay in, and water will follow, and this red cell will what? The red cell will change its shape. The red cell will swell and burst, and there will be hemolysis. So the importance of the sodium potassium ATPs. Remember one time we mentioned that the physiological significance is what? Maintaining cell volume. Okay, so we want the red cell to still maintain its what? Its biconcave shape. Okay, so the sodium potassium ATPase is important for that. Okay, so we also have the calcium magnesium ATPase, which helps in what? Active calcium efflux from the cell. Okay, please don't forget the things we've mentioned. They are quite important. They are little, but they will build up again. Okay, okay, we have pentose. Okay, I think that answers your question, Sarah. There is a pentose phosphate pathway. Okay, yeah, and so, and one of the things I'd advise you is that immediately after this class, please either you go to your PowerPoint or you listen to the video again, so that you don't have to keep it to another time. Also, so the facts will be fresh. And if you're doing that, if you have a textbook by the side, you quickly beef up some material. You'll be glad you did. Okay. So let's quickly look at the functions of red blood cells. Okay, we've mentioned them in passing, but then the first thing is that the red blood cells play an important role in blood viscosity, the blood pressure when the heart is at rest. Okay, so it's important in maintaining what? The diastolic arterial blood pressure. Okay, that's the first function. The second function is hemoglobin is essential for oxygen carriage. It maintains the diastolic arterial blood pressure, the viscosity. The second one we mentioned that because the presence of its hemoglobin also helps in the transport of oxygen and carbon dioxide, and hemoglobin also helps as functions as a buffer. Okay, buffering, uh, accepting hydrogen it is being formed, preventing the pH of the blood from altering markedly. Okay, I just mentioned that the red cell membrane contains glycoproteins and glycolipids. This serves to as what they are specific agglutinogens, right? So they confer uh, uh, some level of specificity on the red blood cells, and we can use that for identifying individuals. Okay, and so let's come to hemoglobin. Let's come to hemoglobin. Okay. I don't. If any other person is following, please indicate. Somebody is indicating that the network is not okay. So hemoglobin. What did we said? The mature red blood cell is enucleated, and it gives space for the compacting of hemoglobin. Okay. What is hemoglobin? Hemoglobin is a chromoprotein. Okay, it's a colored protein with a molecular weight of 64,450, approximately 65,000, and it contains, it's made up of four subunits, each of which contains a heme molecule that is conjugated to a polypeptide chain. Okay, it's a globular protein, it's a chromoprotein, it's made of four subunits. Each subunit has a heme conjugated to what? A polypeptide chain. Okay, each subunit has a heme molecule conjugated to what? To a polypeptide chain. Okay, and the heme is formed of a porphyrin derivative. Okay, which is derived from a porphyrin. Okay, containing one ferrous ion atom. What is ferrous? The ion in the +2 state. So a heme is formed one ferrous atom, and what? And this ferrous atom is ion in what? In the +2 state. Okay, and each hemoglobin contains four ferrous ion and two pairs of polypeptide chains. Okay, these polypeptide chains, okay, the heme is a porphyrin derivative that's derived from porphyrin and contains iron in what? In the +2 state. Okay. So other molecules of the porphyrin family, we have myoglobin, we have chlorophyll, we have cytochrome. So these are, and the hemoglobin is called hemoglobin A. Please take note, it's called what? Hemoglobin A. It's called hemoglobin A. Okay, with an average amount of 15 grams per deciliter. Okay, that is 16 grams in males and 14 grams in females. Of course, it's definitely a range, of course, of 12 to 16 grams. Okay, and we'll come to that again. We'll come to anemia, and we said it contains two pairs of polypeptide chains. So we can say it contains four polypeptide chains. So it contains two pairs. Okay, so you have two alpha polypeptide chains and two beta polypeptide chains. Okay, and each alpha polypeptide chain has 141 amino acids, and each beta polypeptide chain contains 146 amino acids. Okay, so adult hemoglobin A is called alpha 2 beta 2 hemoglobin, meaning that what? It has two alpha polypeptide chains and two beta polypeptide chains. Okay, so it's called adult hemoglobin A, or alpha 2 beta 2 hemoglobin. Okay. So it's quite so we'll proceed, but then I'll come to the other forms of hemoglobin shortly. And to note that the heme is synthesized from glycine and succinyl-CoA. I'm sure you've heard of glycine in your biochemistry. Glycine from glycine and what? Succinyl-CoA. Okay, Mumba, yes, they are the same. Those are blood groups, huh? Yes, they are blood groups. The glycoproteins that are present on the surface, yes, those are what? They are blood groups. Okay. I think Mutipa has answered that. The antigens present on the red cell surface determine blood group. Yes, they are blood group. Okay. So let's look at red cell metabolism. Okay. So far, um, Any questions? But of course, the questions are coming up and we're looking at it. Now, we started by mentioning that the mature red blood cell doesn't have nucleus, it doesn't have mitochondria, it's different. That's the question there somehow. Okay? How then does it survive? So without the benefits of the mitochondria and ribosomes and synthesizing protein, the erythrocyte survives for more than 4 months in the face of repeated oxidative stress and mechanical stress. What brings about the oxidative stress? Of course, higher oxygen concentration and repeated mechanical stress as it is passing through to live for up to 120 days. To live for up to 120 days. The first thing is that it is based on the simplified metabolic organization. And this simplified metabolic organization provides energy for maintaining cellular volume, provides reducing power to protect the cell against oxidation, and help to control the affinity of hemoglobin for oxygen. Please never forget this pathway generate both energy and some metabolites that are used to be able to step. So this simplified metabolic organization produces energy for maintaining the cell volume. Of course, it also provides reducing power to protect the cell against oxidation. And then it also helps control the affinity of hemoglobin for what? For oxygen. The metabolic activities within the red blood cells, most often for generation of energy, we have the pentose phosphate pathway and what? The glycolysis, okay? About 95% of the glucose that is consumed by the red cell is by the pentose phosphate pathway. So the energy produced from glycolysis, which is about four molecules of ATP, that energy is used in the is used by sodium potassium ATPase to maintain what? To maintain the cell volume. Can we still remember the sodium potassium ATPase? And we know what it does, right? It helps in what? Pumping out sodium, therefore maintaining what? The volume of the cell. Okay. Then it also produces a constant supply of what? Of nicotinamide adenine dinucleotide. Reduced nicotinamide adenine dinucleotide, NADH. Okay, I think you must have seen that in biochemistry. It does reduce nicotinamide adenine dinucleotide. Okay, so what does glycolysis produce? It produces two things. Glycolysis produces, there are many things, okay, but within the context of our discussion for now, it produces what? ATP, which is used by sodium potassium ATPase to also maintain the cell volume, and it also produces what? NADH. Okay, what is this NADH? It's a reduced form. Is what? It's a coenzyme. It's a coenzyme. Can we remember coenzyme? Okay, it's a coenzyme that is it's a coenzyme for a reductase enzyme that helps to maintain iron in the hemoglobin in the +2 state. Okay, so we have ATP that is used by sodium potassium ATPase to maintain the cell volume, and we also have what? Reduce NADH, which is a coenzyme enzyme that helps prevents the oxidation of iron from iron 2 to iron 3. What if iron 2 is oxidized to iron 3? Iron 2 is ferrous, iron 3 is what? Ferric. So if it's oxidized to iron 3, we have what we call methemoglobin. Okay? Methemoglobin. Methemoglobin. And so this methemoglobin cannot combine reversibly with oxygen. Okay, this methemoglobin cannot combine reversibly with oxygen. So in the absence of this NADH, the iron 2 in hemoglobin will be oxidized to what? To iron 3. And this gives us what? Methemoglobin that cannot combine reversibly with what? With oxygen. Okay, and so then iron 2, the iron in hemoglobin is also protected by nicotinamide adenine dinucleotide phosphate that is produced from the pentose phosphate pathway. Okay, nicotinamide adenine dinucleotide phosphate that is reduced in NADP. So it is produced, that's one of the products of pentose phosphate pathway. The pentose phosphate pathway produces NADPH, produces ribose 5-phosphate, and also produces pentoses. Okay, the ribose 5-phosphate is used in the synthesis of nucleic acids. NADPH is used in the reduction of the iron 3 to iron, or used in maintaining iron in the +2 state. Okay, it's used in maintaining iron in what? In the +2 state. Then NADPH is also available, is also made available in the cell through its linkage with what? With glutathione. Glutathione. Okay, glutathione is a powerful antioxidant. Okay, protects against oxidation of subhydryl groups of enzymes, globin, and constituents of the membrane. Okay, so what does glutathione do? It provides protection against oxidation of subhydryl groups, So it provides protection against oxidation of subhydryl groups in the globin. And the glutathione also counteracts what? It also counteracts auto-oxidation of membrane lipids and helps to dispose of what? Of hydrogen peroxide. Okay, hydrogen peroxide is a byproduct of so many reactions, and we call it what? It's a free radical. Superoxide free radicals. Yeah, we have superoxide, we have hydrogen peroxide. Okay, so these are oxidants that help to destroy the membrane. Okay, and so we have antioxidants also in the cell that help to ward off these oxidants. Okay, so what did we say the simplified metabolic organization of the red cell does? Provides energy for maintaining cell volume. It also provides reducing power to protect the cell against oxidation, and also help control what? The affinity of hemoglobin for oxygen. Okay, so that we've discussed about, we've talked briefly about the ATP, that the energy that is produced and is used by sodium potassium ATPase to maintain cell volume. We've also talked about the NADH, NADPH, and glutathione that are important for maintaining iron in the +2 state and protecting against auto-oxidation of those subhydryl groups in globin and heme and enzymes and constituents of the cell. Okay, now, but then how does this metabolic organization help facilitate increased oxygen affinity by hemoglobin? So the first, or the thing, one of the products of glycolysis is 2,3-bisphosphoglycerate that is formed from 1,3-bisphosphoglycerate. I think you will do that detailing in biochemistry. And so this 2,3-bisphosphoglycerate reduces the affinity of hemoglobin for oxygen. It reduces the affinity of hemoglobin for oxygen. What do we mean by it reduces the affinity for oxygen? So what that means is oxygen doesn't bind tightly to hemoglobin, so it's easier to be released to the tissues. Okay, it's easier to be released at the tissues. Okay, and this 2,3-bisphosphoglycerate is a product of what? Of glycolysis. Okay, and we'll look at this. I'm sure if If I don't teach you respiration, probably maybe the next lecturer will teach you respiration and we'll look at this in detail. Okay. So let's look at the derivatives of hemoglobin. What are the derivatives of hemoglobin? Please take note of this. So we have there are derivatives of normal hemoglobin that arise due to what? Metabolic changes in the red blood cell. So due to the metabolic changes in the red blood cell, there are different chemical formations or combinations of hemoglobin that arise. Okay, and so we have oxyhemoglobin. So we know that the main function of hemoglobin is to transport oxygen, right, from the lungs to the tissues. Call it what? Oxyhemoglobin. You have oxyhemoglobin. Okay. In the lungs, the partial pressure of oxygen is around 100 millimeters of mercury. The partial pressure of oxygen in the lungs is about what? 100 millimeters of mercury. Okay. And at this partial, okay. So on binding with oxygen in the lungs, hemoglobin is converted to what? To hemoglobin with oxygen at the lungs. And this partial pressure is about 95 to 96%. So this, therefore, oxygen binds to hemoglobin, and this hemoglobin is called what? Oxyhemoglobin. That is the first derivative of hemoglobin. Different forms of hemoglobin that arise as a result of what? Metabolic changes in the red cell. Okay. The next form of hemoglobin is what? Reduced hemoglobin. Reduced hemoglobin. When this oxyhemoglobin has moved to the tissues, where the partial pressure at the tissues drops to about 26 millimeters of mercury, okay, and the percentage per saturation is about just 75%, or so, even less. What happens? This oxygen is released to the tissues, okay, and in turn the hemoglobin binds to hydrogen ion, giving us what we call what? Reduced hemoglobin, or what we call hemoglobinic acid. Okay, we'll look at this detailing. I'm sure the person who will teach you respiration will do that. Okay, but just know that there's reduced hemoglobin. So the next type of hemoglobin, not type, a derivative of hemoglobin, is what? Carbaminohemoglobin. 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 Remember we talked here at the tissues, oxygen is released, and then carbon dioxide is picked. Okay, carbon dioxide is picked. Then carbon dioxide binds to the alpha amino group of the N-terminal end of each of the 4 polypeptide chains of hemoglobin. I'm sure you've started the amino acids, and you know that we have the N-terminal, we have the amino terminal, and what about the carboxy terminal, right? And then we have the alpha amino, the alpha amino group, the one that has what? That is linked to the functional group or to the chiral carbon. So we have alpha amino group, and so we have the carbon dioxide that is picked up from the tissues now combines with the alpha amino group of the N-terminal of each of the 4 polypeptides to give us what we call what? Carbaminohemoglobin. Okay. Then the next derivative is what we call methemoglobin. Okay, methemoglobin. We've talked about it almost. We've mentioned that iron in hemoglobin is is in the ferrous state. Okay, but it can be readily oxidized to the ferric state. What protects it from being oxidized to the ferric state? Number 1, NADH does that. NADPH also helps in that. Okay, so this iron is most readily oxidized to the ferric state. Okay, how it is oxidized by what? It's oxidized by hydrogen peroxide. And this hydrogen peroxide is formed from metabolism in the red cell. Okay, so the hydrogen peroxide oxidizes the iron in the +2 state to what? To iron in the +3 state, forming what we call what? Methemoglobin. And we say this methemoglobin cannot combine reversibly with oxygen. So it's incapable of binding to oxygen. So therefore, the hemoglobin functions are reduced, isn't it? Okay. Normally, about 1.7 to 2.4% of the total hemoglobin will be in the form of methemoglobin. Okay, about 1.7 to 2.4% of the total hemoglobin will be in the what? In the form of what? Methemoglobin. But then this increase in the percentage is prevented by what? By the peroxidase enzyme, or by the peroxidase action of glutathione. Can you remember glutathione? We just mentioned glutathione now. So this activity is prevented by what? By the peroxidase action of what? Of glutathione. Okay. Remember we said it protects against the oxidation of subhydryl groups in globin, in constituents of the membrane, right? Okay. And then the percentage of the bed hemoglobin can be increased if you consume drugs like sulfonamide, quinines, nitrite, ferricyanide. Okay. Now, someone is asking what makes hemoglobin have a higher affinity for carbon monoxide. Okay, we'll come to that. One of the things you have to understand that what it doesn't bind to the iron per se, it binds to the beta portion of the globin, of the hemoglobin, the beta portion, or the beta polypeptide chain. Okay, we'll come to that later on, or probably you will do that with your lecturer or with me in respiration. But the hemoglobin has an affinity for carbon monoxide about 200 to 250 times. Okay, and what does that mean? It means what? Even if you put just a small fraction, or just like a 0.1% of carbon monoxide here, and fill this room with oxygen, the hemoglobin first of all pick carbon monoxide. Okay, and it's irreversible. Okay, and so look at that. Subsequently, is it Naomi? Yeah. Okay. So answer to you, Moses. Okay. Okay. About 1.7 to 2.4% of the total hemoglobin is is methemoglobin. Okay. And remember we mentioned that this methemoglobin high hydrogen peroxide that is formed from red blood cell metabolism, right? And then it is protected by what? By NADH, by the peroxidase activity of glutathione, by NADPH. Okay. Okay. So that is important. And we said individuals who consume things are also what? Prone to have the iron oxidizing to the plus 3 state. Okay. So we also say higher levels are observed clinically in factory workers who inhale aromatic nitro and amino compounds. So you have these factory workers who constantly inhale what? Aromatic nitro compounds and amino compounds. And so, and patients who take large doses of sulfonamides, okay, sulfonamides, and what did I say again? Ferricyanide and acetanilide, okay. Acetanilide, okay. And so, but then as much as this, we could also use methemoglobin. We can use it to overcome cyanide poisoning, okay? By injecting methemoglobin, it combines with cyanide to form cyanomethemoglobin, which now prevents cyanide poisoning, okay? So clinically, methemoglobin can be injected in situations of what cyanide poisoning, and it will combine with cyanide to form what cyanomet hemoglobin. Okay. Then the last one we have is carboxy hemoglobin, which I've just explained. The combination of carbon monoxide, and what, and hemoglobin. Okay. Then we can look at abnormalities of hemoglobin production. So we have the first abnormality, we have what we call hemoglobinopathies. Okay, we have hemoglobinopathies. So hemoglobinopathies, these are conditions in which abnormal hemoglobins are produced, okay? Where abnormal hemoglobins are produced. Okay, so we have several abnormalities are due to what? Mutations in the globin genes, okay? When we have mutations in the globin genes, so abnormal hemoglobins could be produced. So we have more than 3,000 abnormal hemoglobins have been described, but then a few are of clinical significance, okay? A few of clinical significance. So remember we mentioned that hemoglobin A is what? We said was what? Alpha 2 beta 2 hemoglobin, right? It's about alpha 2 beta 2 hemoglobin. And 2.5% of hemoglobin in adult persons is what we call hemoglobin A2. 2.5 alpha 2 delta polypeptide chain. So hemoglobin A2 is normal. Okay. And also normally there are small amounts of what we call glycosylated hemoglobin. Glycosylated or glycated hemoglobin. You said that's hemoglobin A1C. Okay, hemoglobin A1C. Okay, and it has glucose molecule attached to each beta chain. So this is actually the hemoglobin that is used in monitoring the progress of a diabetic condition and how an individual is responding to diabetic drugs or anti-diabetic drugs. Okay. Acetinolide is a drug. Okay, I'm sure it's a drug, and people consuming that drug are prone to having high percentage of their hemoglobin in the form of metabolism. So the quantity of glycated hemoglobin increases in poorly controlled diabetes mellitus, okay, and it decreases with insulin treatment. So the measurement of this glycated hemoglobin is used as an index in evaluating the control of what diabetes. So you have what glycated hemoglobin, okay. So we also have thalassemias. Thalassemia, these are conditions in which the hemoglobin polypeptide chains are okay, they are normal, but then their production is reduced. Either one of them is not produced or all of them are not produced. So the conditions is where the hemoglobin polypeptide chains are normal in structure, but they are produced in decreased quantities, okay? And this could be as a result of what? A defect in the regulatory portion of the gene, okay? A defect in the regulatory portion of the gene. So you could have a deficiency of the alpha polypeptide chain or beta. So you could have alpha thalassemia, beta thalassemia, or you could have alpha beta thalassemia, okay, what we call bad hemoglobin. So this is a situation where all the 4 polypeptide chains are deficient. So you have bad hemoglobin, bad hemoglobin. Bad hemoglobin, okay? So where you have absent of all the polypeptide chains, okay? And then we have hemoglobin F, which is a fetal hemoglobin, and it is normally, this is a hemoglobin that is in the fetus, and it is alpha 2 gamma 2 hemoglobin. Has a high affinity for oxygen than adult hemoglobin, and that means it increases the oxygen carrying capacity. So it has a higher oxygen carrying capacity than adult hemoglobin, and it's always soon replaced with adult hemoglobin after birth. Okay, and then you have hemoglobin S, which is the sickle cell, the hemoglobin in the sickle cell individuals. Okay, and in this type of hemoglobin, the alpha polypeptide chain is normal. The alpha polypeptide chain is normal, but in the beta polypeptide chain, glutamic acid in position 6 is substituted with valine. Okay, glutamic acid is substituted with valine. Okay, substituted with valine. So at low oxygen tension, the hemoglobin S polymerizes, and this causes the red cells to become sickle shaped and hemolyze. Okay, causes the red cells to become sickle shaped and hemolyze and form aggregates, okay, that block blood vessels. Okay, we'll look at that, so we'll come to that. Okay, so the result, this is what brings about, what results in this is that what it results in severe hemolytic anemia called what, sickle cell anemia. Okay, and this kind of anemia is common with black races. Even though it is dangerous or even fatal, it has a benefit because what, sickle cell gene also provides resistance to one type of malaria. And so this brings me to the question for the day, which you add to what you submitted. I've given you 3 questions. The first one was is water. Why does cold water quenches thirst more than warm water? Explain why. If so, why? Uh, then the third question, please. The third question is, how does sickle cell mutation confer protection against certain forms of malaria? Okay, how does sickle cell mutation confers protection against certain forms of malaria? Okay, how does sickle cell mutation confers protection against certain forms of malaria? Please don't just rush over the answer for me. It's just supposed to be half a paragraph, but let it be factual, okay, and let there be a reference, just one reference, okay, just one reference, okay, or at most 2. But don't just read some things. Please search for the information. I read it myself this morning, and it was a great information. So please try to do that. Okay. We are quite far from where I thought we will be today, and okay, we would round up with this. Okay, the question is, how does sickle cell mutation confers protection against certain forms of malaria? How does sickle cell mutation confers protection against certain forms of malaria? Okay. Okay, yes, Mutipa has rewritten the question, so please, you can check the comment section and look at it. There is what I would have loved us to look at today is a fate of hemoglobin, fate or the metabolism of hemoglobin, but it is quite concentrated that I won't want to dive into that. Okay. 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 So okay, so far so good. whoever the Potato Madness is, this is an online class. Okay, so any questions so far? And so next on Friday, we may likely spend a little longer time. This is just 1 hour. I would have gone a little bit to 1 hour, 30 minutes or more than, but then there's a crucial area. Fate of hemoglobin metabolism is quite important. And so I don't want to rush over it. But then in the next class, there are many things I will skip and highlight on the important ones. Okay. I'll skip some things and highlight on the important ones. Okay. Patience, you're asking for the second question in a different class. You should have asked it in the class where it was formed. Okay, ask your classmates. Okay, what was the second assignment for? Okay. Okay, so far so good. Thank you for the time, and then please, I would communicate. I think the class rep will talk with him just now, and you submit the assignment before the next class, before Friday. Okay. I think we would make do with Google Classroom, and I'll communicate the password or what, or the entry code, and then you submit it. And my intention is that we finish erythrocytes, and we would have to finish blood before May 29th. Okay, so we may double the classes, or I'll just make the PowerPoint and send to you, whichever one. Okay. But then, so we want to do that, and we'll have to finish before May 29th, okay? Because I think the term 2 ends in May 29th, and there's a possibility that your assessments commence on June 5th, if I'm not mistaken, or thereabout, everything being equal. Okay, so that's what it would be. So we have to finish blood before that, so that after May, you will start respiration. I don't know whether I'm not sure you won't start it with me, you start it with the other lecturers, okay? Thank you and have a wonderful day, please.